Throughout World War II, German factory workers rebuilt their bombed facilities with grim determination, never understanding why Allied bombs suddenly began landing with surgical precision in 1943. They blamed better pilot training, favorable winds, even divine intervention, anything but the truth. Above them, American bombardiers peered through a device so secret that its existence would reshape the entire air war, and the Germans would die, never knowing it had been perfected years before the first raid. Lieutenant James Mitchell felt the B-17's fuselage shudder as flak burst 300 feet below, black flowers of shrapnel blooming against the pale morning sky over Schweinfurt. It was August 17th, 1943, and he was lying flat in the bombardier's compartment, the plexiglass nose cone offering him an unobstructed view of the German industrial landscape crawling toward him at 180 miles per hour. His hands rested on the controls of the Norden Mark XV bombsight, a 30-pound maze of gears, gyroscopes, and mirrors that the U.S. Army Air Forces had sworn him to protect with his life. During training at Victorville Army Airfield in California, his instructor had been explicit. If this aircraft goes down over enemy territory, your first duty is to destroy this device. Second duty is to survive. In that order. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Mitchell had signed documents pledging to guard the bomb site's secrets. He'd memorized procedures for its demolition. He'd been told that its gyrostabilized optics and automatic trajectory calculations represented a technological leap the Germans couldn't comprehend, a device that could theoretically drop a bomb into a pickle barrel from 20,000 feet. Theoretically. The reality, Mitchell had discovered over the past 4 months of combat missions, was more complicated. The Norden was brilliant, yes, an analog computer of extraordinary sophistication that continuously calculated wind drift, altitude, airspeed, and ballistic trajectory. But it required steady hands, clear skies, and nerves of steel while enemy fighters and flak tried to kill you. 2 minutes to target, came the pilot's voice through the intercom. Captain Robert Vance, a former crop duster from Nebraska, kept his voice level despite the increasing flak. She's all yours, Mitch. Mitchell pressed his face against the rubber eyepiece and began the familiar ritual. His right hand adjusted the crosshairs, tracking the target ball-bearing plant number 4, a sprawling complex of warehouses and machine shops that supplied critical components to German tank production. His left hand spun the rate knob, synchronizing the site's internal mechanisms with their ground speed. The beauty of the Norden, the thing that made it revolutionary, was its gyroscopic platform. Once Mitchell had the target locked in the crosshairs, the bombsight's gyroscopes would hold that precise point in space, regardless of how the aircraft pitched or yawed. The automatic flight control, the bombardiers called it the PDI, or pilot direction indicator, would even fly the plane during the final bombing run, making tiny corrections that no human pilot could match. "Bomb bay doors open," Mitchell reported, flipping the toggle. Cold air screamed through the fuselage. Through the bombsight's optics, Mitchell could see German workers streaming out of the factory buildings, tiny figures running for shelter. Did they know what was coming? Did they understand that the men in the bombers above them could now see individual windows, specific rooftops, precise entry points? Before the Norden, bombing had been almost random bombardiers, dropping their payloads by estimation and hope, sometimes missing targets by miles. Mitchell had read the reports from the early war years. In 1940, British bombers over Germany achieved less than 5% accuracy. Entire raids would obliterate neighborhoods blocks away from their intended targets. But that was before the Norden. 30 seconds, Mitchell called out. His training took over. He made a final adjustment to the trail arm, compensating for the slight crosswind at altitude. The bombsight's mechanical brain did the rest, calculating the parabolic arc of falling ordnance, factoring in air resistance, terminal velocity, the curvature of the Earth itself over long distances. The crosshairs held steady on the main production building's center. "Bombs away!" Mitchell pressed the release and felt the B-17 rise suddenly as 12 500-pound bombs dropped from the racks. Through the bombsight, He watched them fall, not scattered randomly, but in a tight pattern, a stick of destruction that walked directly across the target building like the footsteps of an invisible giant. The first bomb struck the northwest corner, the second hit 15 feet away, the third, fourth, and fifth bombs marched across the roof in a precise line. Mitchell counted the impacts, watched the roofs collapse inward, saw the secondary explosions as something volatile inside fuel storage, maybe, or chemical baths for the metalworking caught fire and added its own violence to the destruction. "Good bombing," Vance's voice crackled over the intercom. "Very good bombing. Let's get the hell out of here." As the B-17 banked away from the target, Mitchell caught a glimpse of the other bombers in their formation, 43 B-17 seconds from the 91st Bombardment Group, each carrying a Norden sight, each delivering their payload with the same precision. Below, the ball-bearing plant was already obscured by smoke, but Mitchell knew what the reconnaissance photos would show tomorrow: targeted destruction, surgical strikes that had eliminated specific buildings while leaving others intact. This was the secret the Germans didn't understand. This was why their factories were dying. The Norden Bombsight story began not in wartime desperation but in peacetime ambition, created by a man who'd never dropped a bomb in anger. Carl Norden was a Dutch engineer who'd emigrated to America in 1904, a meticulous perfectionist who'd spent 2 decades designing gyroscopic stabilizers for naval fire control systems. In 1921, the US Navy approached him with a problem. Aircraft were becoming weapons platforms, but hitting anything from a moving plane was essentially impossible. Could precision bombing even work? Norden thought it could. He retreated to his workshop in New York City and emerged 8 years later with a prototype that seemed like something from science fiction. The Mark XV bombsight, the version Mitchell used over Schweinfurt, was the culmination of Norden's obsession with precision. It weighed just over 30 pounds but contained more than 2,000 moving parts, gears meshing with jeweler's precision, gyroscopes spinning at 7,200 revolutions per minute, optical elements ground to tolerances of 1/10,000th of an inch. At its heart was a gyrostabilized platform that remained perfectly level regardless of the aircraft's motion. Mounted on this platform was a telescopic sight connected to an analog computer, mechanical, not electronic, that could solve differential equations in real time. The bombardier would identify his target, input the aircraft's altitude and airspeed, and then track the target through the optics. As he tracked, the bombsight's mechanisms would automatically calculate drift angle, ground speed, and the precise moment for bomb release. But Norden's true innovation was the automatic pilot interface. During the final bombing run, the bombardier could engage the PDI, which sent electrical signals directly to the aircraft's autopilot. The bombsight would literally fly the plane, making corrections too small and too rapid for human pilots to execute. In those final 30 seconds before bomb release, the machine was in control, holding the aircraft steady while the bombardier refined his aim. In testing at Muroc Dry Lake in California, the Norden achieved results that seemed impossible. Bombardiers dropped bombs from 20,000 feet and hit targets 200 feet in diameter with greater than 50% accuracy. In peacetime exercises with perfect conditions, some bombardiers managed to land practice bombs within 50 feet of the aim point, an accuracy rate that would remain unmatched until guided missiles decades later. The U.S. Army Air Corps, later the Army Air Forces, recognized immediately that this device could change warfare. They classified everything about it as top secret and began a production program that would eventually cost $1.5 billion, more than the Manhattan Project in its early years. By 1943, the Norden Bombsight production line at the factory in Stamford, Connecticut, was operating around the clock. Each site took 150 hours to manufacture. Workers with security clearances assembled components in separate rooms, none of them understanding how the complete device functioned. The gyroscopes came from one contractor, the optics from another, the computing mechanisms from a third. Only at final assembly did the pieces come together. Every bombsight had a serial number logged with its assigned aircraft and bombardier. When Mitchell received his Norden at Victorville, he'd signed for it like it was made of gold and diamonds. In a sense, it was worth more, because this device, multiplied across thousands of bombers, represented America's ability to destroy Germany's industrial capacity without having to fight through every mile of occupied Europe. But the Norden had a critical weakness, one that the air forces tried desperately to hide. It required clear skies. Major General Ira Eaker understood the problem better than anyone. As commander of the 8th Air Force in England, he'd watched American bombers attempt precision daylight raids against German targets through the winter of 1942–43, and the results had been disappointing. The Norden Bombsight was a fair weather device. Cloud cover below the bomber formation made precision bombing impossible. Bombardiers couldn't see their targets through solid overcast. Smoke screens could blind the optics. Even heavy haze reduced accuracy dramatically. And Europe, particularly Northern Europe, where most German industry clustered, was cloudy. Weather data showed that on average, only 7 days per month offered the clear conditions that Norden bombing required. The British had already learned this lesson the hard way. In 1940 and 1941, RAF Bomber Command had attempted precision raids against German industrial targets using their own sophisticated bombsights. The results were catastrophic not because the technology failed, but because British bombers, forced to operate at night to avoid German fighters, couldn't see their targets. Post-raid analysis revealed that most bombs fell miles from their intended aim points, scattered across German cities in patterns that looked almost random. The British response was to abandon precision entirely. By 1942, under Air Marshal Arthur Bomber Harris, RAF Bomber Command had adopted area bombing massive night raids designed to destroy entire urban areas rather than specific factories. If you couldn't hit a factory, Harris reasoned, burn down the city around it, kill the workers, destroy their homes, break civilian morale. The Americans recoiled from this strategy. Area bombing seemed like terror warfare, indiscriminate destruction that violated the emerging laws of armed conflict. More pragmatically, Air Force commanders believed precision strikes against specific industrial targets would be more effective at destroying Germany's war-making capacity than burning residential neighborhoods. The Norden Bombsight offered a way to make precision bombing work, but only if the weather cooperated. Eaker's solution was audacious. Large-scale daylight raids using tight bomber formations that could defend themselves with concentrated machine gun fire. Each bomber would carry a Norden sight. If they could reach the target in clear weather and maintain formation despite German fighters, they could put hundreds of bombs precisely onto industrial complexes. It was a gamble that would either revolutionize strategic bombing or get thousands of American airmen killed. The test came in the summer and fall of 1943, with a series of raids against German ball bearing production. Ball bearings were critical components. Every tank, aircraft, and artillery piece needed them. German production was concentrated in a few cities, particularly Schweinfurt. If American bombers could destroy these plants using Norden precision, they might cripple German armored warfare. Mitchell's August 17th mission was part of this campaign. The results seemed promising. Reconnaissance photos showed devastating accuracy, but the cost was staggering. Of the 230 bombers that raided Schweinfurt that day, 36 were shot down and 122 damaged. Nearly 20% losses in a single mission. A follow-up raid on October 14th, quickly dubbed Black Thursday, was even worse. Of 291 bombers dispatched, 77 were lost and 121 damaged. More than 600 airmen killed or captured in one afternoon. The 8th Air Force couldn't sustain such losses. The raids were suspended, and for weeks, strategic bombing advocates wondered if daylight precision bombing could work at all, Norden sight or not. What they didn't yet understand was that the Norden's real impact wouldn't come from individual bombing runs, but from the cumulative effect of mass raids operations so large that even German air defenses couldn't stop them. By early 1944, everything changed. Not because the Norden improved the bombsight's technology remained essentially unchanged from its 1943 configuration, but because American industrial production finally caught up with strategic ambitions. Captain Thomas, Henderson arrived in England in February 1944 and couldn't believe what he saw. The 8th Air Force, which had struggled to launch 200 bomber raids in 1943, now had more than 1,500 heavy bombers operational, with more arriving weekly. Airfields dotted eastern England like mushrooms after rain, sprawling complexes of runways, hard stands, maintenance facilities, and barracks that had transformed the British countryside into the world's largest military airbase. Henderson was a bombardier with the 384th Bombardment Group, stationed at Grafton Underwood. His B-17, which he'd named Fortune's Favour with his crew, carried a Norden Mark XV sight identical to thousands of others throughout the 8th Air Force. The scale of operations now dwarfed anything attempted in 1943. Where early raids had involved 40 or 50 bombers, mission planners now routinely ordered 800 to 1,000 aircraft into the sky simultaneously. The logistics were staggering, coordinating takeoffs from dozens of airfields, assembling formations over England, navigating to targets deep in Germany, all while maintaining tight defensive boxes that could concentrate fire against attacking fighters. Henderson's first mission, a raid against aircraft factories in Leipzig on February 20th, 1944, involved 938 bombers, nearly 1,000 aircraft, each carrying a Norden sight, each capable of precision bombing. The preparation ritual began before dawn. Henderson and his crew were roused at 0300 hours, fed a breakfast of powdered eggs and coffee that tasted like burnt oil, then herded into the briefing room where the mission map was revealed like a magic trick, the curtain pulled back to show a red line stretching from England deep into central Germany. Leipzig, the intelligence officer announced. Primary targets are the Erler Maschinenwerk and ATG aircraft assembly plants. Secondary targets include the central rail yards. Expected opposition: heavy. Mission having worn away the novelty. Altitude: 24,000 feet. Bomb load: 12 500-pounders. Expected cloud cover: scattered to broken, clearing over target. That last detail was critical. The Norden needed visibility. In the equipment room, Henderson collected his Norden sight from the armory cage, signed for it, and carried it out to Fortune's Favour like a priest bearing a sacred relic. The bombsight lived in a heated cabinet when not in use, protected from moisture and temperature extremes that could throw off its delicate calibration. Installing the sight was a 15-minute procedure. Henderson mounted it on its bracket in the nose compartment, connected the electrical cables that linked it to the aircraft's autopilot, checked the gyroscope bearing temperature, verified the level bubble alignment. Each Norden was calibrated specifically for its assigned altitude and typical bombing conditions. Henderson's sight was optimized for 20,000 to 25,000 feet, the sweet spot where German flak was less intense, but oxygen and temperature were still manageable. The bomber stream began forming up over England at 0700 hours. Henderson watched from the nose as bombers climbed through broken clouds. The formations gradually taking shape, tight boxes of aircraft stacked vertically, each box containing 8 to 21 bombers flying wingtip to wingtip. This was the key to surviving German fighter attacks. Concentration. A single bomber was vulnerable, but a formation of 21 bombers could bring more than 200 machine guns to bear in any direction. German fighters learned quickly to avoid head-on attacks against tight formations, but that meant the formations had to stay tight, which required extraordinary skill from pilots flying just feet apart at 180 miles per hour. By 0800, the entire force was assembled 938 bombers in 44 combat boxes, stretching across 50 miles of sky. Fighter escorts, the new P-51 Mustangs with drop tanks that could accompany the bombers all the way to the target, wove protective patterns above and beside them. Henderson had 3 hours to think during the flight to Leipzig, 3 hours to watch the English Channel slide beneath them, then the occupied territories of Holland and northern Germany. 3 hours to wonder if this mission would be his last. The flak began 40 miles from Leipzig, black puffs of smoke at their altitude, German 88mm and 105mm guns firing proximity-fused shells timed to explode near the bomber formations. Henderson felt each nearby burst through his boots, the concussion rippling through the aircraft's frame. Then they were over Leipzig, and Henderson pressed his face to the Norden's eyepiece. The city sprawled below, still partially obscured by morning haze, but clearing rapidly. Henderson could see the Erla factory complex, 6 large buildings in a geometric arrangement, connected by rail lines. Intelligence photos had identified each building's function: final assembly, engine installation, weapons fitting, paint shops. Bomb bay doors open, Henderson called out and began his tracking procedure. Here was the Norden's terrible beauty. Through the optics, magnified 12 times, Henderson could see individual buildings, roads, even vehicles moving through the factory yards. The crosshairs tracked smoothly as he turned the rate knob, compensating for wind drift. He engaged the PDI and felt the aircraft's controls go dead as the bombsight took over flying. Around him, 20 other bombers in his box were doing the same thing. 21 bombardiers, 21 Norden sights, all tracking the same target complex. When Henderson released his bombs, the others would drop on his signal 21 aircraft, dumping 252 bombs in a pattern that would saturate the target area. Bombs away. Henderson held his breath and counted 1001, 1002, then felt the impacts more than saw them. The Erla complex disappeared beneath a rolling carpet of explosions, 252 bombs falling, within 30 seconds, covering the entire facility in fire and destruction. As fortune's favour banked away from the target, Henderson caught glimpses of what 938 bombers could do. Leipzig was burning. Not just the aircraft factories, the entire industrial district was obscured by smoke from hundreds of separate fires. The Norden sights had delivered their payloads with precision, but multiply that precision by nearly 1,000 bombers, and the cumulative effect was obliteration. This was the secret the Germans still didn't understand in early 1944. It wasn't just the Norden's accuracy that made it devastating. It was the Norden's accuracy multiplied by American industrial capacity. One precision bomb sight was merely impressive. 1,000 precision bomb sights, all operating simultaneously against a single city, was apocalyptic. Oberst Friedrich Müller stood in what remained of the Erla factory and tried to comprehend what he was seeing. It was February 21st, 1944, one day after the Leipzig raid, and the devastation defied belief. Müller commanded industrial defense for the Luftwaffe's central region, which made this catastrophe his responsibility to explain. For the past 6 months, he'd been filing reports about increasingly accurate Allied bombing, but his superiors at Luftwaffe headquarters dismissed his concerns. Better pilot training, they said. Lucky weather conditions. Pure chance. But this wasn't chance. Müller walked through the rubble of Building 4, the main assembly hall, and counted bomb craters. 14 direct hits on a structure 200 feet long and 80 feet wide, not scattered randomly across the factory complex, but concentrated on the most critical building, the one structure whose destruction would paralyze aircraft production. The Americans knew. Somehow, they knew which buildings mattered. Müller had studied engineering at Technical University in Berlin before the war. He understood ballistics, trajectory calculations, the physics of falling objects. To achieve this level of accuracy, the American bombardiers would need sophisticated targeting equipment, something far beyond simple optical sights. He'd captured American airmen, interrogated them about their equipment and methods. Most knew nothing useful, but a few bombardiers had mentioned their bombsight in cryptic terms, always carefully avoiding details. One lieutenant, badly burned and drugged with morphine for pain, had whispered about the Norden before catching himself and refusing to say more. Müller filed reports about a possible American precision bombing device. He requested intelligence assets investigate. He even suggested that captured bombsights be sent to technical analysis centers. The response from Luftwaffe headquarters was dismissive. Oberst Müller was seeing patterns that didn't exist. Precision bombing from 20,000 feet was theoretically impossible. German engineers had studied the problem and concluded that the mechanical tolerances required couldn't be manufactured. The Americans were simply lucky, Or perhaps they were dropping more bombs than German intelligence estimated. What Müller couldn't know was that German intelligence had in fact captured Norden bombsights from crashed aircraft. At least 4 intact examples had reached technical evaluation centers by early 1944. German engineers had examined them, documented their mechanisms, even attempted to reverse engineer their function. But they'd concluded the devices were inferior to German bombsights. The Norden's mechanical computing system seemed crude compared to German optical designs. Its reliance on gyroscopes appeared wasteful. German engineers favored direct optical tracking. The automatic pilot interface was dismissed as unnecessary complexity. Most critically, German evaluators tested captured Nordens under laboratory conditions and found them finicky and temperamental. The gyroscopes required careful handling. The optical elements needed frequent calibration. In German hands, the bombsights didn't perform any better than standard equipment. What German engineers failed to understand was that the Norden wasn't just a piece of hardware, it was part of an integrated system. American bombardiers trained for 6 months specifically on the Norden, learning its quirks and capabilities. American maintenance crews had specialized tools and procedures for keeping the sights calibrated. American pilots flew steady courses during bomb runs, specifically to maximize the Norden's effectiveness. Strip the device from its operational context, and it was just an expensive collection of gears and mirrors. Integrate it into a comprehensive bombing system with trained operators and coordinated tactics, and it became devastating. Müller suspected something like this, but couldn't prove it. Standing in the ruins of Leipzig's aircraft industry, he knew the Americans had achieved something Germany couldn't counter, not because of any single technological advantage, but because of system-level integration that the Luftwaffe couldn't match or even fully understand. He filed another report, this one more urgent. The Americans were clearly using advanced bombsights that enabled precision targeting. Germany needed to either develop countermeasures or decentralize industry to make precision targeting less effective. The report vanished into the bureaucratic machinery of the Luftwaffe command structure. By the time it might have prompted action, events had overtaken analysis. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Staff Sergeant Raymond Cooper had never seen so many bombers in one place. It was March 6, 1944, and he stood on the hardstand at Kimballton Airfield, watching B-17 seconds taxi into position as far as he could see a river of aircraft flowing toward the runway, propellers churning the cold English air into a deafening roar. Cooper was a flight engineer on Dixie Demon, part of the 379th Bombardment Group, and today's mission briefing had been unprecedented. The target was Berlin, the German capital itself, and the 8th Air Force was sending every operational bomber it possessed. More than 1,200 heavy bombers, escorted by 700 fighters, the largest air armada ever assembled. The mission represented a fundamental shift in American strategic thinking. In 1943, raids had targeted specific industrial complexes with surgical precision. But by spring 1944, the strategy had evolved into something more overwhelming. Saturate entire industrial regions with so many precision-guided bombs that even partial accuracy would guarantee destruction. Cooper's bomber carried the now familiar Norden Mark XV, tended by their bombardier, Lieutenant Arthur Vasquez, a soft-spoken Mexican-American from El Paso who treated the device with religious reverence. Vasquez had explained the mathematics to Cooper once, sketching diagrams on notebook paper in their barracks. At 24,000 feet, with the Norden dialed in perfectly, my bombs land within 300 feet of the aim point maybe 70% of the time. Doesn't sound impressive, right? But multiply me by 800 bombardiers, all targeting the same factory complex. Even if we're all off by 300 feet in random directions, we still obliterate everything within a half-mile radius. The concept was mathematically elegant and tactically brutal. Individual precision, multiplied by overwhelming numbers, created area devastation that exceeded the accuracy of any single bombsight. Dixie Demon climbed into the grey morning sky at 0742 hours, joining a stream of aircraft that stretched for miles. Cooper stood in the top turret position, watching the formation assemble with choreographed precision. The sight never lost its power. Hundreds of aircraft stacking into combat boxes, the entire formation resembling some vast mechanical organism floating through the clouds. The flight to Berlin took 4 hours. German controllers tracked them on radar from the moment they crossed the Dutch coast, and Luftwaffe fighter wings scrambled to intercept. But by March 1944, German fighter defenses were crumbling under the same numerical pressure that made American bombing so effective. For every Messerschmitt or Focke-Wulf that rose to attack, there were 5 American P-51 Mustangs waiting to engage. Cooper watched dogfights streak past at closing speeds exceeding 600 miles per hour. Quick bursts of tracers, aircraft spinning away trailing smoke, parachutes blossoming like dandelions. The sheer scale of combat was unprecedented. At one point, Cooper counted 37 separate aerial engagements visible from his turret position simultaneously. Then they were over Berlin, and the flak began in earnest. German anti-aircraft defences around the capital were the heaviest in Europe, more than 400 heavy guns arranged in concentric rings, firing shells timed to explode at specific altitudes. The gunners didn't aim at individual aircraft. They saturated altitude zones with shrapnel, creating killing boxes that bombers had to fly through. Cooper felt each nearby burst through his boots, watched shrapnel punch fist-sized holes through the wings of adjacent bombers. One B-17 inches their formation took a direct hit. The shell penetrated the fuselage just behind the cockpit and detonated inside. The bomber crumpled in mid-air like a paper bag squeezed in a fist, then fell away, tumbling, scattering men and debris. But the formation held. 1,200 bombers, even losing dozens to flak and fighters, still represented overwhelming force. Vasquez's voice crackled over the intercom. "I've got the target. IP in 30 seconds. The initial point, the last navigation checkpoint before beginning the bomb run. From here, the bombardiers took control. Cooper couldn't see what Vasquez saw through the Norden's optics, but he'd toured enough bombed cities to imagine. Berlin spread below them, a patchwork of industrial districts, residential neighborhoods, government buildings, and rail yards. Somewhere down there was their primary target, the Daimler-Benz tank engine factory in Marienfelde. The Norden's telescopic sight would show Vasquez the factory in extraordinary detail, individual buildings, rail sidings, smokestacks. He would track the main assembly building through the crosshairs, the bombsights mechanisms calculating wind drift, ground speed, ballistic trajectory. The PDI would take control of the aircraft, making micro-corrections to keep the crosshairs steady. Bomb bay doors open. Cold air screamed through the fuselage. Cooper watched the formation around them, saw other bombers opening their bay doors in synchronized movements, exposing the cylindrical shapes of 500-pound bombs racked in neat rows. "Bombs away!" Vasquez's release triggered ripple drops throughout the formation. 1,200 bombers didn't drop simultaneously. The formations were staggered, with lead aircraft dropping first and following aircraft bombing on visual cue. The effect was a rolling curtain of explosions that walked across Berlin's industrial districts for 90 seconds. Cooper caught glimpses through breaks in the smoke, the Daimler-Benz complex disappearing under multiple direct hits, secondary explosions throwing debris hundreds of feet into the air, entire blocks of factory buildings collapsing into rubble. The Norden sites had guided their bombs with precision, but the sheer volume of ordnance, more than 3,000 tons dropped in 90 seconds, created destruction that transcended precision. It was industrial annihilation. As Dixie Demon banked away from Berlin, Cooper saw what 1,200 bombers with precision bombsights could do. The city's southern industrial districts were obscured by smoke columns rising thousands of feet. Fires burned in dozens of separate locations. Rail yards that had been geometric patterns of tracks and switches were now cratered wastelands. The Germans could rebuild, they'd proven remarkably resilient at reconstruction. But the raids would continue tomorrow, and the next day, and the day after that. American industrial production was now delivering 250 new heavy bombers per month. German production of fighter aircraft was roughly equivalent, but Germany also had to defend the Eastern Front against the Soviets, maintain coastal defenses, protect Mediterranean supply lines, The mathematics were inexorable. Every raid cost the 8th Air Force bombers and crew today's mission would lose 69 aircraft, more than 690 men killed or captured. But those losses could be replaced within 2 weeks. German industrial capacity, once destroyed, took months to rebuild, if it could be rebuilt at all. This was the Norden's real strategic impact, not the precision of individual bombing runs, but enabling a scale of sustained operations that made German industrial defense impossible. General Karl Tui Spaatz stood in the operations room at 8th Air Force Headquarters in High Wycombe and studied weather reports with the intensity of a gambler calculating odds. It was February 19th, 1944, and meteorologists were predicting a rare window of clear weather across Central Europe, 6 to 7 days of optimal visibility. Spaatz commanded U.S. strategic air forces in Europe, which made him responsible for implementing the bombing strategy that would either cripple German war production or waste thousands of American lives in futile raids. The Norden Bombsight gave him precision capability, but precision required clear skies, and clear skies over Germany in winter were rare as diamonds. The weather window represented an opportunity that might not come again for months. Spaatz made his decision: maximum effort operations against German aircraft production for the entire week. Every operational bomber, every available crew, every Norden site in the inventory, all committed to destroying Germany's ability to produce fighters. What followed would be called Big Week, 6 days of sustained bombing operations that would demonstrate the full potential of precision bombing at scale. Lieutenant Colonel Marcus Ashford flew every mission of Big Week as a lead bombardier with the 91st Bombardment Group. His experience illustrated both the capabilities and limitations of the Norden in sustained operations. February 20th, Leipzig Aircraft Factories. Ashford's target was the Junkers assembly plant, a sprawling complex producing Ju-88 bombers for the Luftwaffe. Through his Norden's optics, he could see the facility in remarkable detail, despite attacking from 24,000 feet. The main assembly building was 600 feet long, with a distinctive curved roof. Ashford tracked the center point, engaged the PDI, and released his bombs at the precise, calculated moment. The bomb pattern was nearly perfect, 10 of 12 bombs impacted within the factory perimeter, with at least 4 direct hits on the assembly building itself. Reconnaissance photos the next day would show the building's roof collapsed along its entire length, production machinery buried under tons of structural steel. But Ashford's perfect bombing run was just one element in a larger tapestry. The Leipzig raid involved 417 bombers, each carrying a Norden sight, each targeting some portion of the city's aircraft industry. The cumulative effect was overwhelming. Every major aircraft plant in Leipzig was hit, some by multiple bomb groups. Production ceased entirely for 3 weeks. February 21st, Brunswick. Ashford flew again, targeting Messerschmitt component factories. The weather was deteriorating. Scattered clouds at their bombing altitude forced some bombardiers to drop through gaps in the overcast. Ashford got lucky with clear air over his target, and his Norden guided bombs onto a machine shop producing wing sections for Bf 109 fighters. February 22nd weather recalled most missions. Ashford spent the day in his barracks, cleaning and recalibrating his Norden sight. The device required constant maintenance. Gyroscopes needed rebalancing, optical elements needed cleaning, the rate computer needed lubrication. Ashford had learned to treat the bomb sight like a temperamental racehorse. Careful handling, constant attention, and respect for its capabilities and limitations. February 24th, Schweinfurt ball-bearing plants again. This was the 3rd major raid on Schweinfurt, and German defences were ready. Flak was intense and accurate, fighters attacked in waves, and bomber losses were severe. But Ashford's formation put bombs directly onto the Kugelfischer ball-bearing works, and reconnaissance would later show production machinery destroyed beyond repair. February 25th, Regensburg Messerschmitt factories. Ashford flew his 5th mission in 6 days, feeling the accumulated exhaustion of sustained combat operations. His hands shook slightly as he aligned the Norden's crosshairs fatigue, degrading his precision despite the bombsight's mechanical perfection. His bombs still hit within the target area, but scattered more widely than his earlier missions. This highlighted a reality that American planners sometimes forgot. The Norden was only as good as its operator. A fresh, well-rested bombardier could achieve remarkable accuracy. An exhausted bombardier flying his fifth mission in 6 days would be less precise, despite using identical equipment. But here again, scale compensated for individual variation. Even with fatigue degrading individual accuracy, operations involving hundreds of bombers still delivered overwhelming destructive power to target areas. By the end of Big Week, American and British bombers had dropped more than 10,000 tons of bombs on German aircraft production facilities. The 8th Air Force alone flew 3,300 bomber sorties, individual aircraft missions guided by 3,300 Norden Bombsights. German fighter production dropped by 25% over the following 2 months, not just from direct bomb damage, but from disruption of component supply chains, loss of skilled workers, and chaos in the transportation network. More significantly, the Luftwaffe lost nearly 450 fighter aircraft defending against Big Week raids, along with approximately 300 pilots killed or seriously wounded. These were losses Germany couldn't replace. The Reich had aircraft factories, but pilot training took months, and experienced fighter pilots were irreplaceable assets. Ashford survived Big Week, but barely. His bomber took flak damage on 4 of 5 missions. 2 engines shot out over Schweinfurt, hydraulics damaged over Regensburg, the tail gunner killed by fighter attack over Leipzig. Each time, they limped back to England, landed safely, and prepared for the next mission. The Norden sight in Ashford's aircraft functioned perfectly throughout, a testament to both the device's robust design and the meticulous care Ashford invested in its maintenance. The bombsight didn't care about flak or fighters or exhausted crews. It simply calculated trajectories with mechanical precision, mission after mission, converting American industrial capacity into precisely targeted destruction. Captain William Brennan stood in the interrogation room at Dulag Luft, the Luftwaffe's main interrogation center for captured Allied airmen near Frankfurt, and wondered how much he should reveal. It was April 1944, 3 weeks after his B-17 had been shot down over Augsburg, and the German intelligence officer across the table was asking about American bombsights. Brennan had been a bombardier with the 305th Bombardment Group. He'd flown 17 missions using a Norden Mark XV, and he'd signed documents swearing to protect its secrets even under interrogation. But the documents hadn't prepared him for the reality of capture, the uncertainty about whether he'd survive the war, the isolation from other prisoners, the subtle, psychological pressure of interrogators who seemed to know far more than they should. The interrogator, a Luftwaffe Hauptmann who spoke perfect English, asked specific questions about bombing procedures. What equipment did American bombardiers use? How did they aim their bombs? What explained the increasing accuracy of American raids? Brennan gave the standard responses drilled into him during training: name, rank, serial number, and nothing else. The Hauptmann nodded sympathetically, made notes, and asked different questions that seemed unrelated but circled back to the same topics. After 3 days of interrogation, Brennan was moved to Stalag Luft III, the main prisoner camp for Allied Air Force officers in eastern Germany. There, he met hundreds of other captured bombardiers, and their conversations revealed an extraordinary situation. The Germans knew about the Norden. They'd captured examples from crashed aircraft. They'd interrogated dozens of bombardiers. They had detailed technical intelligence about the device's mechanisms and capabilities, but they didn't understand it. Not really. Second Lieutenant James Kirby, shot down in January 1944, described his interrogation experience. They showed me photographs of a Norden sight must have been from a crash site, asked me to explain how it worked. I gave them nothing, but they kept asking the same questions, like they couldn't figure out the basics. They knew it had gyroscopes, knew it connected to the autopilot, but they couldn't understand how the whole system integrated. The paradox was that German technical intelligence was actually quite good. They'd captured Norden sites largely intact. They'd photographed them, disassembled them, documented every component. German engineers at testing facilities had examined the devices with Teutonic thoroughness, but they'd evaluated the Norden in isolation, as a standalone device, and concluded it wasn't significantly better than German optical bombsights. What? German intelligence failed to comprehend was the systemic integration, the specialized training American bombardiers received, the maintenance procedures that kept the sights calibrated, the tactical formations that maximized bombing effectiveness, the industrial capacity that could deploy thousands of sights simultaneously. First Lieutenant Robert Shaw, a bombardier shot down over Berlin, explained it to fellow prisoners. They've got the hardware, but they don't have the doctrine. They look at the Norden and see an overcomplicated optical sight. They don't see the whole system, the training, the tactics, the mass production. It's like handing a carburetor to someone who's never seen a car and asking them to understand how automobiles work. The German interrogators at Dulag Luft actually reinforced this misunderstanding through their ABA questions. They asked about the Norden's mechanical specifications, its optical magnification, its gyroscope design. They asked technical questions that suggested they viewed it as a precision instrument that should be evaluated like any other military equipment. They never asked the right questions. How did American training produce bombardiers who could use the device effectively? How did maintenance crews keep thousands of sites operational across hundreds of dispersed airfields? How did mission planning exploit the Norden's capabilities at scale? These were system-level questions that required understanding American military organization, industrial capacity, and strategic doctrine. German intelligence, brilliant at tactical analysis of individual weapons, struggled with systemic evaluation of integrated capabilities. The result was a catastrophic intelligence failure. By mid-1944, German commanders understood that American bombing accuracy had improved dramatically, but they attributed it to factors they could comprehend: better pilot training, improved weather forecasting, numerical superiority, the possibility that a single device, properly integrated into a comprehensive bombing system, could enable precision targeting from 20,000 feet seemed improbable to German analysts who'd tested captured Nordens and found them unimpressive. Brennan and his fellow prisoners discussed this situation with a mixture of relief and frustration. Relief that German interrogators weren't extracting useful intelligence even when they had access to the actual hardware. Frustration that the war was clearly turning against Germany, yet German leadership seemed unable to comprehend why. In the barracks at Stalag Luft III, bombardiers traded stories about their most accurate missions, comparing bombing patterns and discussing the Norden's capabilities with a professional pride that transcended their prisoner status. These conversations revealed the psychological dimensions of the Norden's impact. For American bombardiers, the device was more than equipment. It was proof that precision could triumph over brute force, that American technological ingenuity could match German military power. The Norden represented a peculiarly American approach to warfare. Apply industrial methods, engineer solutions to tactical problems, trust in technology to provide advantages that courage alone couldn't achieve. For German interrogators and intelligence analysts, the Norden represented a puzzle they couldn't solve because they asked the wrong questions. They looked for a secret weapon, a technological breakthrough that would explain American bombing accuracy. What they needed to see was a system training, plus technology, plus tactics, plus industrial scale that was greater than the sum of its parts. Captain Richard Torres, shot down in March 1944, summarized the situation in a letter he managed to smuggle out through the Red Cross. They have our bombsights, but they're still losing. They can take the Norden apart, down to the last gear and mirror, and it won't help them, because the Norden isn't the secret. The secret is everything around it, the factories producing thousands of them, the schools training thousands of bombardiers, the doctrine that uses them effectively. They're looking for magic when they should be looking at manufacturing. By late 1944, several hundred American bombardiers were held in German POW camps, most of them trained on the Norden, many of them eager to discuss their experiences with fellow prisoners. The Germans could have learned everything about the Norden simply by listening, but they didn't know how to listen. They heard technical details but missed strategic insights. They documented hardware but failed to understand doctrine. This was perhaps the Norden's greatest victory. Not the precision of its bombing, but the cognitive blindness it induced in German intelligence. They knew the weapon existed, possessed examples of it, interrogated its operators, and still failed to comprehend its true significance until American bombs had destroyed Germany's industrial capacity. Hauptmann Klaus Weber stood in what remained of the lunar synthetic oil plant and tried to calculate how long it would take to rebuild. It was May 1944, and American bombers had just conducted their fourth raid on this facility in 6 weeks. The devastation was so complete that calculation seemed pointless. Weber was an engineer conscripted into overseeing industrial reconstruction, a job that had become increasingly futile as Allied bombing intensified. The lunar plant had been one of Germany's most important installations, producing synthetic fuel from coal through the Fischer-Tropsch process. The Reich needed this fuel desperately. Natural oil supplies from Romania couldn't meet military demands. The April raid had damaged 30% of production capacity. Engineers had worked around the clock for 2 weeks to restore some output. Then the Americans came back. Through his binoculars, Weber had watched the second raid from a shelter 3 miles away. The bomber formations had been enormous, more than 400 B-17 seconds and B-24 seconds, and their bombing had been terrifyingly precise. He'd watched bombs fall in patterns that seemed almost surgical, targeting specific buildings within the sprawling complex. The hydrogenation plant, direct hits that collapsed the structure and destroyed the catalytic reactors. The coal processing facility bombs that penetrated the roof and detonated inside, scattering machinery and rupturing pressure vessels. The storage tanks, incendiary bombs that ignited residual fuel and created an inferno that burned for 18 hours. What stunned Weber wasn't just the destruction, but the precision. The bombs weren't scattered randomly across the facility. They concentrated on critical structures, bottlenecks in the production process, where damage would be most difficult to repair. The Americans knew which buildings mattered. Walking through the ruins after the raid, Weber found evidence of extraordinary accuracy. One bomb had struck the main control building within 15 feet of its center, precisely where the electrical distribution panels would have been located. Another had hit the primary cooling tower at its base, toppling the entire structure. These weren't lucky hits, they were aimed shots. German intelligence had briefed him on American bombsights, mentioning a device called Norden that supposedly enabled precision targeting. But intelligence had assured him the device's capabilities were exaggerated, that precision bombing from 20,000 feet remained largely impossible, regardless of equipment. Standing in the lunar ruins, Weber knew intelligence was wrong. The Americans were hitting specific targets within factory complexes from 4 miles up. They were doing it consistently, in multiple raids, against different facilities across Germany. This wasn't luck or accident. It was systematic precision enabled by technology Germany didn't possess. Weber's experience was replicated across German industry in 1944. At every critical installation, aircraft factories, ball-bearing plants, synthetic fuel facilities, tank production centers, engineers watched American bombers deliver precision strikes that specifically targeted the most vulnerable points in their operations. The cumulative effect was catastrophic. German industrial production in 1944 should have peaked, labor mobilization was complete, factories were optimized, years of wartime production had refined manufacturing processes. Instead, output began declining in virtually every category. Aircraft production dropped despite massive efforts to expand capacity. Tank production stagnated as component suppliers were bombed. Most critically, fuel production collapsed by September 1944. Synthetic fuel output had fallen to 30% of its April levels, strangling German mechanized operations. What made the situation hopeless wasn't just the initial damage, but the systematic re-attacks. German engineers would restore partial production, and American bombers would return within weeks to destroy it again. The Norden Bombsights enabled this systematic approach precise enough to hit specific buildings within factories, allowing bombers to target the same critical structures repeatedly. By autumn 1944, Weber and engineers like him across Germany were fighting a losing battle. They could rebuild faster than bombs destroyed only if the raids stopped, which they wouldn't. American industrial production was accelerating more bombers, more bombs, more Norden sights, while German defenses weakened under attrition. Weber witnessed the final stage of this process at the Ruhland synthetic fuel plant in October 1944. The facility had been hit 3 times already, and each time engineers had restored partial production through heroic effort. The October raid involved more than 500 bombers, and their precision was almost casual bombs falling onto already damaged structures, finishing what previous raids had begun. After that raid, Weber submitted a report to his superiors, stating that reconstruction was no longer practical. The Americans could destroy facilities faster than Germany could rebuild them. The solution wasn't better engineering. It was ending the war before American bombing destroyed every industrial installation in the Reich. The report was ignored, but events proved Weber correct. By December 1944, German fuel production had effectively ceased. Tank units sat immobilized for lack of gasoline. Fighter aircraft were grounded, while bombers overhead destroyed German cities. The Luftwaffe had aircraft but no fuel to fly them. This was the Norden Bombsight's final devastating impact, not individual precision, but sustained systematic destruction that made industrial defense impossible. German engineers could rebuild damaged factories, but they couldn't rebuild fast enough to outpace precision bombing sustained at scale. The irony that Weber noted in his personal diary was that Germany possessed captured American bomb sites, had studied their mechanisms, had interrogated their operators, but had never understood that the device's significance lay not in its technology, but in its systematic application. "We studied the instrument," Weber wrote in December 1944, "but failed to comprehend the doctrine. We saw the hardware and missed the strategy. They didn't beat us with a better bomb sight. They beat us with 10,000 better bomb sites, operated by trained crews following integrated tactics supported by industrial capacity we couldn't match. By the time we understood this, understanding was irrelevant." Colonel Richard Hughes stood in the interrogation facility at RAF Tangmere in southern England, examining a German intelligence report captured in May 1945, days after the war's end. The document was titled Analysis of American Precision Bombing Capabilities and dated March 1945, one of the final intelligence assessments produced by the collapsing Third Reich. Hughes commanded technical intelligence evaluation for the U.S.'s strategic air forces in Europe, which made him responsible for understanding what the Germans had known about American bombing technology. The captured report stunned him. German intelligence had possessed accurate technical data about the Norden Bombsight since late 1943. They'd captured at least 9 intact examples from crashed aircraft. They'd photographed every component, documented the mechanical systems, even conducted test trials using captured devices. The report Hughes held described the Norden's gyrostabilized optics, its analog computing mechanisms, its automatic pilot interface, all documented with engineering precision. German analysts had understood the hardware completely, but the report's conclusions were baffling. After pages of accurate technical description, the assessment concluded that the Norden offered only marginal improvements over German bomb sites, and that American bombing accuracy resulted primarily from numerical superiority rather than technological advantage. "They knew everything and understood nothing," Hughes muttered to his assistant, Lieutenant Morrison. Morrison, who'd flown 28 missions as a bombardier before transferring to intelligence, nodded grimly. "They saw the trees and missed the forest, sir. They evaluated the Norden as a piece of equipment instead of as part of a system." This was the final irony of the Norden's war. The secret that won the air campaign wasn't really secret at all. Germans possessed the hardware, interrogated its operators, documented its capabilities, but failed to comprehend its strategic significance because they asked technical questions when they needed to ask doctrinal ones. Hughes spent weeks after the war interviewing captured German intelligence officers, trying to understand this cognitive failure. The pattern that emerged was consistent. German analysts, brilliant at tactical evaluation of weapons systems, struggled with systemic analysis of integrated capabilities. They'd evaluated the Norden in isolation and found it unimpressive, temperamental, difficult to maintain, no better than German optical sights under laboratory conditions. What they'd missed was that American bombardiers trained for 6 months specifically on the device, that maintenance crews had specialized procedures, that tactical doctrine exploited its capabilities, that industrial production could deploy thousands simultaneously. Oberst Friedrich Müller, the Industrial Defense Commander Hughes, interviewed in June 1945, explained it succinctly. "We kept looking for the secret weapon that explained your bombing accuracy. We never considered that the secret might be organization, training, and industrial capacity rather than technology. We understood the bombsight. We never understood the system that made it effective." The Norden Bombsight remained classified until 1947, when the technology was finally declassified and its specifications published. By then, the device was already obsolete. Radar bombing systems were emerging that could target through clouds, and guided missiles would soon make precision bombing possible without bombsights at all. But during its critical years, 1943 to 1945, the Norden had enabled American air forces to destroy German industrial capacity through sustained precision bombing at scale, not because it was a secret weapon, but because it was a systematic weapon, one component in an integrated approach to strategic bombing that the Germans captured, studied, and failed to counter because they never understood what they were fighting against. Hughes filed his final report in August 1945, concluding, "German intelligence possessed complete technical knowledge of the Norden bombsight by early 1944. This knowledge proved strategically worthless because understanding hardware doesn't equate to understanding doctrine." The Norden's success resulted not from keeping it secret, but from applying it systematically at scales the enemy couldn't comprehend or counter. "We won the bombing campaign not by hiding our capabilities, but by executing doctrine the Germans couldn't match even when they knew what we were using." The report disappeared into classified archives, another document explaining how America won the air war. The Norden bombsights themselves, thousands of them, were eventually scrapped or sold as surplus 30-pound relics of analog computing that had helped destroy the Third Reich, not through technological secrecy, but through systematic application that the Germans captured, examined, and failed to understand until American bombs had reduced their industrial capacity to rubble. Staff Sergeant Raymond Cooper, who'd flown his last mission in February 1945, returned home to Indiana and stored his Norden manual in a footlocker in his attic. He never spoke much about the war, but sometimes he'd take out the technical drawings and remember those missions over Germany, remember the precision of the device, the mathematics of destruction, the strange truth that the greatest secret of the Norden wasn't that it existed, but that its true power lay in multiplication. One bombsight was impressive. 1,000 bombsights, operated by trained crews following integrated doctrine, was apocalyptic. The Germans never understood this until it was too late, and by then understanding was merely academic, a footnote to a war already lost, destroyed by precision they could see but couldn't comprehend. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.